Hi students, how are you? Once again, welcome back to our lecture series on plus 2 mathematics. Today, we are going to discuss about some board examination questions which are based on graphs. See, if you can visualize a mathematical problem graphically, then you can very easily solve the problem, that too without using mathematical formula. See, before entering into the video, let me remind you something. If you didn't subscribe my channel yet, do subscribe it now itself, and don't forget to press the bell icon also. Okay. Now let us go directly to your board examination questions, which are based on graphs. See, the first question is, consider the following graphs: f of x, g of x, h of x, and p of x, and you are required to complete this table. So the table is the function is discontinuous at x equal to, continuous but not differentiable at x equal to, the applicability of Rolle's theorem is the third part. So now let us examine each of these graphs and let us understand whether each of these graphs is continuous, differentiable, or whether Rolle's theorem can be applied or not. So the first question is this, first graph is this. So this is the graph of the function f of x. So how will you understand whether the graph is continuous or not? If the graph does not have a break, if the graph of the function does not have a break, then the function will be continuous. So this function is continuous. Here the f of x is continuous because the graph of f of x does not have a break. How about this function? This function also is continuous because this function does not have a break. How about this function? This function is discontinuous at x equal to, or this function is not continuous at the point x equal to, because corresponding to the point x equal to, there is a gap in the graph of the function. So since there is a gap corresponding to x equal to, we can say that the function is discontinuous at x equal to. So this function h of x is discontinuous at x equal to 2. So discontinuous at x equal to 2. How about this function? This function again, this function does not have a break. See, at this point there is a corner point corresponding to x equal to. This sharp point is called corner point. So corresponding to x equal to, there is a corner point. Still the function is continuous because the graph of the function does not have a break. This also, sorry, that's the next question. See, these are the four graphs. So here, all these three functions, f of x, g of x, and p of x are continuous because the graph does not have break. But for this function, there is a gap corresponding to x equal to. Therefore, this function h of x is discontinuous at x equal to 2. So, which function is discontinuous at x equal to? It is h of x. So, here you will have to write h of x. Next, let us check the differentiability. So, by using graphs, how can we check whether a function is differentiable or not? See, if a function is not differentiable, if f of x is not differentiable, if the function f of x is not differentiable, first condition is that it will be discontinuous, differentiable at x equal to a, discontinuous at x equal to a. Second is corner point at x equal to a. So the f of x is not differentiable at x equal to a if f of x is discontinuous at x equal to a, or f of x has a corner point at x equal to a. One more point is there, f of x has a, what we can say, vertical tangent at x equal to a. So in all these three cases, f of x is not differentiable at x equal to a. So what are the three cases under which f of x is not differentiable? First is discontinuity at x equal to a. Second condition is that there is a corner point at x equal to a. And what is the third condition? There is a vertical tangent at x equal to a. So in all these cases f of x is differentiable at x equal to a. So here we will have to check that differentiability at x equal to 2. So here at x equal to 2 the function is continuous because corresponding to x equal to the function does not have a break, and also corresponding to x equal to the function is differentiable because corresponding to x equal to the function does not have a corner point or a vertical tangent. So this function is differentiable and continuous. Similar is the case with the function g of x. This function is also differentiable because this function is continuous and this function does not have corner point. See, how about this function? This function is discontinuous at x equal to 2. Therefore, this is not differentiable at x equal to 2. See, this function, since it is discontinuous at x equal to 2, it is not differentiable at x equal to 2. The function is not differentiable at x equal to a if it is discontinuous at x equal to a. So here the function is discontinuous at x equal to 2, therefore the function is not differentiable at x equal to 2. Here, corresponding to x equal to 2, there is a corner point. So this function is not differentiable at x equal to 2. So let us continuous but not differentiable at x equal to 2. What is that? This function is continuous. This function is continuous but not differentiable at x equal to 2 because corresponding to x equal to there is a corner point. So if there is a corner point at x equal to a, then f of x is not differentiable at x equal to a. So here corresponding to x equal to there is a corner point, so this function is not differentiable at x equal to, but it is continuous at x equal to because corresponding to x equal to there is no gap. So this function is continuous at x equal to, but since there is a corner point at x equal to, it is not differentiable at x equal to. So what is the function, or which is the function which is continuous but not differentiable at x equal to? It is the function p of x. So here you will have to write p of x. Third, Rolle's theorem is applicable in the closed interval 0, 4. See, in order to apply Rolle's theorem, what is the condition? F of 0 must be equal to f of 4. See, for the applicability of Rolle's theorem, f of a is equal to f of b. This is one of the conditions of Rolle's theorem. So the other two conditions are f of x must be continuous and differentiable, and also f of 0 is equal to f of 4. Here we can say that f of 0 is equal to 1, f of 4 is also 1. So for this function, f of 0 is equal to 1, f of 4 also is equal to 1. So f of 0 is equal to f of 4 for this function. And also this function is both differentiable and continuous. So Rolle's theorem is applicable for the function f of x. So for the function f of x, Rolle's theorem is applicable because the function does not have a break. So f of x is continuous. Since the graph of f of x does not have a break or a corner point, the function is differentiable. And also f of 0 is equal to f of 4 is equal to 1. So all the conditions of Rolle's theorem are satisfied by the function f of x. It is continuous, differentiable, and f of 0 is equal to f of 4. So for the function f of x, we can apply Rolle's theorem in the closed interval 0, 4. So for how about this function? For this function is continuous, and also this is differentiable. Why this is differentiable? Because this function does not have a break and this function does not have a corner point. But here we will have to check the applicability of Rolle's theorem in the closed interval 0, 4. So, but what is f of 0? F of 0 is this point. What is f of 4? F of 4 is somewhere here. This is f of 4. So f of 0 not equal to f of 4. See, so here f of 0 not equal to f of 4. For f of 4, there f of 0 is a negative number and f of 4 is theorem cannot be applied. This is not differentiable at x equal to, so for this function Rolle's theorem cannot be applied. So Rolle's theorem is applicable in closed interval 0 for the function f of x. See, now I think this problem is quite clear to you. Let us move to the second rule. See, this is a higher secondary examination, board examination question in the year 2019. Model examination. See, let us go to the second question. See, write the function whose graph is shown below. Discuss the continuity and differentiability of the function. So here, how will you write the function f of x? This is a higher secondary examination March 2019 question. This question is also based on graphs. How do you write this function f of x? See, first of all, discuss the continuity and differentiability of the function. See, using this graph itself, by viewing this graph, we can simply understand whether the function is continuous or differentiable. See, the function does not have a break, so this function is continuous. Right? This function is continuous. How about the differentiability? So corresponding to x equal to 0, there is a corner point. So this function is not differentiable at x equal to 0. So we can understand that without using mathematical calculations. So that is the advantage of graphical analysis. So if you can analyze a problem graphically, if you can visualize a problem graphically, you can solve the problem very easily without using mathematical formulae. Okay, so this function does not have a break. The graph does not have a break, so this function is continuous. But to check the differentiability corresponding to x equal to 0, there is a sharp point or there is a corner point. So the function is not differentiable at x equal to 0, not differentiable at x equal to 0, but the function is continuous. The function is not differentiable at x equal to 0 because corresponding to x equal to 0, there is a corner point or there is a sharp point. And since there is no gap, the function is continuous. Now, how will you define the function f of x? Write down the function whose graph is shown below. See, suppose x is less than or equal to 0. If x is less than or equal to 0 means this part. When x is less than or equal to 0, the graph passes through minus 1, 1 and minus 2, 4. See, what is the equation of this graph? F of x is equal to x square. Then what is f of minus 1? F of minus 1 is minus 1 square, that is plus 1. What is f of minus 2? Minus 2 square, that is plus 4. And again, this is a part of the parabola open upwards. See, what is the equation of the parabola which is open upwards? Which is f of x is equal to x square. So what is f of minus 1? F of minus 1 is minus 1 square, that is plus 1. What is f of minus 2? Minus 2 square, that is plus 4. So what is the equation of this graph? F of x is equal to x square. F of x is equal to x square. So f of x is equal to x square when x is less than or equal to 0. When x is greater than or equal to 0, that means this part. When x is greater than 0, what is the equation of this graph? This graph is a straight line passing through the point 1, 1, 2, 2. Here both x and y values are equal. So what is the equation? F of x is equal to x. So f of 1 is equal to 1, f of 2 is equal to 2, f of 3 is equal to 3. What is the equation of this line? F of x is equal to x. So this is the function given in the problem. So f of x is equal to x square when x less than or equal to 0 and f of x is equal to x when x greater than 0. So what will be f dash of x? We can write f dash of x directly from here. So if f of x is equal to x square, what is f dash of x? Derivative of x square, 2x. That is when x less than or equal to 0. And what is if f of x is equal to x, what is f dash of x? Derivative of x, that is 1 when x is greater hand derivative at x equals 0? At x equals 0, left hand derivative means x is less than 0. That is this point. Simply substitute x equals 0 here. So left hand derivative at x equals 0, that means x less than 0. That is 2x. 2 into 0. 2 into 0 is 0. What is right hand derivative at x equals 0? To find out the right hand derivative at x equals 0, we must consider x greater than 0. When x greater than 0, what is derivative? F dash of x is equal to 1 is 1. So here left hand derivative at x equals 0 is 0, but the right hand derivative at x equals 0 is 1. That is left hand derivative not equal to right hand derivative. So since left hand derivative not equal to right hand derivative, we can say that the function is not differentiable at x equal to 0. But the function is continuous at x equals 0, since the graph of the function does not have a break corresponding to x equals 0. But for corresponding to x equals 0, the function or the graph of the function has a corner point. Therefore, corresponding to x equals 0 or at x equals 0, the function is not differentiable. So how will you check the differentiability of a function using graph? If f of x is not differentiable at the point x equals a, if f of x is discontinuous at x equal to a, or f of x has a corner point at x equal to a, or one more thing is that f of x has a vertical tangent at x equal to a. In all these cases, f of x will not be differentiable at x equal to a. So I think these two problems are quite clear to you. Let us move to the next problem. Now let us go to the third problem. So here we are given the graph of f dash of x. We are given the graph of not f of x, but the graph of f dash of x is given. You are required to find out the intervals in which f of x is increasing or decreasing, points of local maxima and local minima. See, if f of x is increasing, f dash of x will be positive. If f of x is increasing, f dash of x will be positive. That means f of x is increasing at intervals in which the graph of f dash of x is above x-axis. Is it clear? If f of x is increasing, what is the condition? F dash of x is positive. This is the graph of f dash of x. So here we can say that in this portion f dash of x is positive because this portion is above x-axis. Here at this point also, at this region also, f dash of x is positive because in these two regions f dash of x is positive because the graph of f dash of x is above x-axis. So what is this interval? This point is minus infinity. So this interval is minus infinity minus 1. So f of x is increasing, and how? This is minus infinity minus 1, and this interval is plus infinity. This interval is 3 infinity. So first answer to the first part. Find the intervals in which f of x is increasing or decreasing. So f dash of x is positive in these two intervals, minus infinity minus 1 and 3 infinity. So f of x is increasing in minus infinity minus 1 union 3 infinity. Why f of x is increasing in this interval? Because in these two intervals the graph of f dash of x is above x-axis, or f dash of x is positive. Since f dash of x is positive in these two intervals, the function f of x is increasing in these two intervals. How about the interval at which the function is decreasing? If f of x is decreasing, f dash of x will be less than 0 or f dash of x will be negative. So if f dash of x is negative, the graph of f dash of x will be below x-axis. So this is the x-axis. So at this portion or in this interval, the graph of f dash of x is below x-axis. So in the interval -1, 3, f of x is increasing. So what is the second point? Second point. Find the points of local maxima and local minima. So how do you find out the points of local maxima and local minima? At the points of local maxima and local minima, f dash of x is equal to 0. Is it clear? At the points of local maxima and local minima, f dash of x is equal to 0. So find out the points at which f dash of x is equal to 0. So at this point x equal to -1, f dash of x is equal to 0. At this point also f dash of x is equal to 0. So f dash of, this is the graph of f dash of x. So f dash of x is equal to 0 at the points in which the graph of f dash of x intersects the x-axis. So at the points -1 and 3, f dash of x is equal to 0. This is -1, 0 and this is 3, 0. So at the points -1 and 3, f dash of x is equal to 0. So the function has local maxima and local minima at x equal to -1 and at x equal to 3. See, at x equal to -1, what happens? At the point x equal to -1, here f dash of x is positive and here f dash is negative. So at the point -1, f dash of x changes its sign from positive to negative. So at the point x equal to -1, f dash of x changes its sign from positive to negative. So at this, so before x equal to -1, f dash of x is positive, and after x equal to -1, f dash of x is negative. So at the point x equal to -1, f dash of x, here f dash of x is positive, but here f dash of x is negative. So at the point x equal to -1, f dash of x changes its sign from positive to negative. So if f dash of x changes its sign from positive to negative, it is a local maximum point. Local maximum point. So what is the condition at a local maximum point? At a local maximum point, f dash of x changes its sign from positive to negative. So at this point what happens? See, here f dash of x is negative. The graph is below x-axis. So here f dash of x is negative, but here f dash of x is positive. So at the point x equal to 3, f dash of x changes its sign from negative to positive. Therefore x equal to 3 is a point of local minima. Point of local minima. So what is the condition at the point of local minima? At the point of local minima, f dash of x changes its sign from negative to positive. And at a point of local maxima, f dash of x changes its sign from positive to negative. You must understand this thing. So I think this problem is quite clear to you. Let us go to the next problem. So here we are given the graph of f dash of x and f of x. Here we are given the graph of f of x and f dash of x. This is the graph of f dash of x and this is the graph of f of x. So you are given, you are asked 3 questions. Identify the points of local maxima and local minima. How do you identify the points of local maxima and local minima? So this is the graph of f dash of x. At the points of local maxima and local minima, f dash of x is equal to 0. That means f dash of x crosses x-axis. So at x equal to 0 and x equal to 2, f dash of x intersects the x-axis. Or this is the point 0, 0 and this is the point 2, 0. So at x equal to 0 and x equal to 2, the points of local maxima and local minima are x equal to 0 and x equal to 2. See, at x equal to 0, what happens? This is the graph of f dash of x. At x equal to 0, here f dash of x is positive because the graph is above x-axis. But here f dash of x is negative. At this point, f dash of x changes its sign from positive to negative. If f dash of x changes its sign from positive to negative, this is a local maximum point. So x equal to 0 is a local maximum point. But at the point x equal to 2, f dash of x, this is the graph of f dash of x. Here f dash of x is negative, but here f dash of x is positive. So at the point x equal to f dash of x changes its sign from negative to positive, or f dash of x is a point of local minima. So x equals 0 is a point of local maxima and x equal to 2 is a point of local minima. That you can understand from the graph of f of x also. This is the graph of f of x and this is the point of local maxima and this is the point of local minima. So at this point x equals 0. So local maximum occurs at x equals 0 and this is the point local minimum and that occurs at x equal to 2. So local maximum and local minimum occurs at x equals 0 and x equal 2 respectively. Find the intervals in which f of x is increasing or decreasing. See, if f of x is increasing, what is f dash of x? If f of x is increasing, f dash of x will be greater than 0. So f dash of x is greater than 0 means the graph of f dash of x will be above x axis. So the graph of f dash of x is above x axis at this region and also at this region also f dash of x is above x axis. So this is minus infinity 0, minus infinity 0 union. This point is to infinity, to infinity. So at minus infinity 0 and to infinity, so in the interval minus infinity 0 union to infinity, f of x is increasing or f dash of x is positive. See, f dash of x is negative in the interval 0 to. See, in the interval 0 to, in the upper interval 0 to, the graph of f dash of x is below x axis or f dash of x is negative. So f of x is decreasing in 0 to. So in the interval 0 to, f of x is decreasing and in this interval f of x is increasing. Increasing means the graph of f dash of x is above x axis. Decreasing means the graph of f dash of x is below x axis. So find the corresponding interval. Second, find the absolute maximum and absolute minimum of f of x in minus 1, 4. See, absolute maximum means maximum of maximum is called absolute maximum, the greatest value. The least value is called absolute minimum. So this is the graph of f of x. So this is the highest point, that is absolute maximum. What is the absolute maximum value? 10. So absolute maximum value is equal to, absolute maximum value is equal to 10. And what is the least value or minimum value? This is the graph of f of x. So this is the least value. This is the highest value, which is 10. What is the least value? Corresponding to x equal to minus 1 and x equal to, which is minus 10. So absolute maximum value is 10 and absolute minimum value is minus 10. So absolute maximum value 10 occurs at the point x equal to 4. And absolute minimum value minus 10 occurs at the points x equal to minus 1 and x equal to 2. So if you can analyze a problem graphically or if you can visualize a problem graphically, you can very easily solve the problem. So graphical analysis is very